Record. Okay, you can go to presentation mode.
Right. Thank you. All right, we'll start now. Hello and welcome everyone. My name is Rajendra Mishra, and along with me, I have Yogindra. So today we will be talking about the orchestration of the Magma 5G code using AMCOP. So this particular session will go into the details of the steps that we followed and how we were eventually able to orchestrate this entire setup in the Kubernetes cluster. So we list down the agenda. We'll talk a little bit about what is Magma, very brief of it. Then the components that we used, AMCO, CDS that comes from the ONAP umbrella, and then a high level view of how the setup was, how the different clusters were, and then how we basically configured it and then we're able to deploy it and make it running. So towards the end, we have a recording where we will showcase all the steps in detail, and we'll talk about all the REST APIs that we used or whatever steps we used for the orchestration process. So if we go to the next slide, then just for our introduction, Magma is an open source platform that allows you to deploy a 5G core, and primarily it consists of like 5G, all the 5G components like UPF, AMF, and SMF. It has more than that, but our focus has been primarily on around 5G. So it allows you to deploy that in a Kubernetes cluster, and that's what we will be doing as a part of the setup. If we go to the next slide. So the components that we used, so we used EMCO, which is primarily used for the orchestration of all these packages into Kubernetes cluster. And along with that, we use the GUI, which will allow us to create the services and the service instance and networks and all for this Magma package that we have. And in addition to that, we had CDS, which comes under the ONAP umbrella. And from there, like, we are able to create a CBA that can do day-end configuration for the Magma controller. So as a part of the configuration, we'll go more in more details as we go to the recording and all, but at a high level, as a part of the configuration, we were able to set up keys and hardware keys and IDs and all onto the controller. So going to the next slide, Yogindra. So this diagram describes how the clusters were set up. So at this point, I'll hand it over to Yogindra to cover into deeper details of how the setup was and the steps that we followed for doing this deployment. Yogindra? Hey, you are on mute, Yogindra. I can't hear you.
Okay, yeah, thank you. Thank you, Api. So we're going to just tell how our setup looks like, and and how the various components are residing into it, and then the overall workflow, and then we'll actually look at the demo itself. Right. So you can see there is a 2 VM setup. What we have it, the VM1, which we have named as an AMCOP, which is residing on an 192.168.101.224 IP address, and it has one management cluster. Kubernetes cluster, and in that we have done is we have made AMCOP deployed into it, which is nothing but our EMCO, and also on the same setup we make use of the EMCO to deploy the Magma controller itself, right? And then you have on the right hand side the KUD VM, which is on 192.168.102.46 on a different network, and they are connected through the router. And this KD cluster is primarily we are exercising for bringing up the access gateway of the Magma, right? And which is running as a workload today in that setup. And the orchestration of the access gateway is also being taken care by the EMCO in this case. And that's how our setup looks like. And what we've done is after the deployment of the Magma controller and the access gateway, there is a step where the access gateway has to be registered back with the Magma controller, then Magma controller here is nothing but the NMS element, right? So that's why we bundled the Magma controller and the EMCO into the one cluster, and we're calling it as a management cluster. And the target cluster is for any network functions which will be doing the data plane of it. Right? So that is how the setup looks like. So what you see here, the steps, so like 1, 2, 3, and 4, they are primarily involved in terms of doing the automation, wherein we are saying that the CBA, right, the CBA which is going to get exercised from the CDS, that is going to do an SSH from this VM all the way to the second VM, KUD VM, and then from there it's going to connect to the access gateway and fetch back the hardware ID and the challenge key of the access gateway, which identifies that access gateway, and then bring it back in the CBA and then use that to connect with the Magma controller using the REST interface of the Magma controller itself. So you can do various operations on that interface. That could be a register, an access gateway, or unregister it, or you have to fetch a get operation and see the status of any of those information. So these are the 4 fundamental steps. And what we have done is we have automated all of them into one CBA. And that is what we're going to show you in the demo also. Okay, so demo is split into 2 parts. First would be to orchestrate the Magma controller and the access gateway. And the second would be doing the automation, which is what we're saying as Magma automation CBA. Okay. So, and the details which I just spoke about is, primarily again, we have slightly zoomed in and presented in this slide, which is in a next level of information. But we're not going to go into that detail at this point of time, but it's more interesting to see the demo itself. So I'll take you to the demo. In the demo, just to put the expectation correct there. So what we're going to do is we're going to do an orchestration of Magma components using EMCO GUI. And then we do the automation where we'll demonstrate get operation, and then unregister an access gateway, and then register an access gateway. All the 3 events we're going to demonstrate.
Again, can I ask one quick question?
Yeah, go ahead.
Yeah, I just wanted to understand. You said that CDS is predominantly used to automate where you get some kind of a key from AGW and then program Magma controller, right?
Correct.
Is that the reason? And then you also mentioned, I didn't catch that. How do you get that key from AGW? Is it using SSH, or is it some kind of a RESTful API?
Okay, so there is what's interesting part. So AGW is today a worklet, right? It's like a virtual machine, right? VM. So you have to, so if you look at it, this management cluster is separate in a different network, right? They're not in the same network, right? So you have to SSH all the way from here to this network, first of all. And then when you land in this cluster, you need to do another SSH to this AGW. And then AGW has a built-in script, which they call it show gateway info. From there, when you run that Python script, it will create that hardware key and the challenge key. And that is what has to be fed back to the Magma controller.
Is that the only way you can get that hardware key, or is it is there any RESTful API or some other function?
This is interesting. So I've asked these guys, from the Magma community. So right now it's a manual, these guys do it. So what you have to do is you have to go and fetch this from that, and then take that information and go into the UI, and as in a manual way, feed that information, and then you register it. So that's the pain problem. So that's why we are automating that, by this way. So CBA is capable of doing, automation very nicely.
So Srini, right now it is run under a wattlet. Eventually, when it becomes fully cloud native and it can be deployed as a pod, I believe like it will be much faster to do it through REST APIs. So right now this is like we deploy a VM inside the cluster, and then in that VM, this entire AGW application runs.
Thank you. Okay.
Yeah. So basically, the moment
is that the only thing which you do in based on CDS today, or do you do anything else? Is that the only functionality?
No, you can do lots more. I mean, it depends upon the workflow, right? Which workflow you wanted to perform. Based on that, you will define your CBA.
No, I understand from this Magma project perspective. Whatever you did so far, what automation did you do using CDS? One is this automation of this hardware key into Magma controller.
Correct.
So in this demo, did you do anything else using CDS? That's the only thing for now.
No, so only for this demo, we just did only this much part, register and the get part. Yeah.
Okay, thank you.
Yeah, so the target was to demonstrate that all kinds of configurations can be done, and in this, like as a part of the CBA that we build, it calls the REST APIs, and it can do other configuration also, like getting the different connecting to the HEW and doing whatever configurations that are done using the GUI today. But for this particular setup, we are demonstrating it using using this SSH, and then showing that like we can get the key and register it, and this entire process of deploying it can be fully automated.
Correct. Yeah. Honestly, for all the day-in operations, you can do more. You can create the respective CBAs, based on what configuration you wanted to deploy, right? So that is open, and it is slightly based on what scope you wanted to exercise it. So in today's setup, we just wanted to demonstrate just registering part of it, because you can have many access gateways, right? And so registering is one of the basic first step of it. So at least we wanted to show that, and then you do subsequently more.
Okay. So what you're saying is that that's what is current scope in this demo, but there are more opportunities in this setup to do automation, maybe such as maybe automating subscribers.
Yes. Yeah. I mean, actually, you can do a lot. In fact, the good part is in Magma controller, and they have a lot of interfaces. The REST APIs has been exposed. One can use that to do that. They can create a network, and on top of the network, you can monitor that network, and you can do things like that. So maybe one of the get operations which I'll show that shows that capability one can extend. I mean, one can build observability in the CBA, and then keep monitoring it.
So maybe let me just add to that, Srini, maybe to answer your question, which we did not ask, can this be done without CDS, directly using only EMCO, right? That's the answer is probably yes. I think all of this can be eventually done just with EMCO. But our goal was to do it in such a way that the same thing can be used for both ONAP as well as for EMCO direct. So I think that's the reason we.
Yeah, the reason I'm asking these questions are basically to there was one request in EMCO community, right, to add temporal to EMCO, and then provide ability in EMCO to call different temporal workflows at different LCM stages, right? Application LCM stages, to allow something like this, whatever you just now described. Sometimes you need to get hold of these hardware keys using some other protocol. They are not Kubernetes CRDs, or they are not RESTful APIs. There could be something else. And also we also heard one more use case where in Azure IoT case also you need to get some API key from some hub and then program it in some IoT service in the edge. So some of these things we are also kind of getting that request from various community members, right? So we are planning to add temporal. I'm just in that context, I was trying to see what are the use cases we can test once we add that feature. So one is that Azure IoT Hub, and second one is maybe Magma. So that's the context I was asking these questions. Anyway.
Okay. Yeah. Thank you, Srini. So let's go to the demo now. Okay. So here from the UI, right, one can create. And this is the 1012.224 where we are actually doing the AMCOP or the EMCO GUI. One can create the tenant, right? We have already created a tenant by name demo, right? And in the tenant, if you just enter and see, there are a bunch of services which we have already created, and service instances are also up and running, and the cluster attached to it, right? That details are there. So if I further wanted to see what is inside the logical cloud, so we have created two logical clouds. One of them is for the AMCOP and the Magma controller, that is cloud, And the second cloud 2 is where we have the KUD running in today, second VM. So going into services, I want to show that one can add services within, by going that path, or there is pre-existing ones which we are showing there, and the service instances also. So the workflow is basically one has to go for a tenant, and tenant will have in the tenant you can create an onboarding of the cluster, and then you can create logical clouds inside it, and then you instantiate, create a service inside it, and then instantiate the service itself. So that's how the overall workflow would look like, right? So here one can terminate a service instance. So I'm going to just demonstrate that a demo access gateway, I already had it, so I just terminated it, and we're going to create a new service instance where we'll deploy the access gateway. Okay, for this demo, I have already what I have done is the controller part, Magma controller, I have already instantiated and kept it because so that will save some cycles there. And we're just demonstrating immediately the access gateway part of it. Okay. So here, this was the previous one which I had it, which is sitting as a state. Now I'm going to create a new one. Yeah, add service. I'm going to do it, and I'm going to fill in the details. So I'm picking up a name there. Magma access gateway and description to it, and then I'm going to add the application here. So the name has to match with the Helm chart. There's access gateway ADW. We have picked it up, and then that's where you have to upload your Helm chart and the config override files. So I'm going to just do that now. And then do the submit of it. So that way you create one service. So you have one service now, right? And now in that service, one can actually go and instantiate that service. You have to create an instance of it. So you go into service instance, right? And then create a service instance. And in service instance, you'll select the service which you just created. I take a instance name here. Deploy access gateway. I picked any version there. This was just a representation because access gateway 1.6, which was getting exercised. So I just picked up a name there. You can select the service there and description and the logical cloud. So in our case, logical cloud is the cloud 2 because you have KUD sitting in there. And this is where you put your placement. So we selected the KUD 1. This is where our this cluster has this access gateway has to reside in. Then we select the secondary network. This is one because we wanted one interface towards the controller and one interface towards the eNode B, right? So that's why we have the another network inside it. And once you do that, we are ready to instantiate it now. So we're going to click this and we're going to instantiate it. And this is how your access gateway is getting instantiated on the KUD cluster. One can verify that it is deployed, and we will go back at the Kubernetes cluster and we'll check that. Yeah, so this is the second VM 102.46, the way we showed it in the topology initially. We're going to get pods, and yeah, here is that. You'll see that 28 seconds. So it just now created. So it is going to boot up now. So let's attach to it and just see what is the status of it. So we'll attach to this pod. So it takes a bit of time to come up. It takes around 20-25 minutes. So once it boots up, right? So it does a bunch of initialization inside it with its scripts, and then you have this show gateway info script, which will be able to generate that hardware ID key and the challenge key. Right? Okay, so we waited for some time, and then let's see whether it has come up or not. It's still coming up. Yeah, so this is a file which should these start details. We waited for some more time. Let me just speed up this. Yeah, it's there. So here I'm pausing up. So you will see here, this is a hardware ID, and this is the challenge key. These two are the information which you have to feed back to the NMS controller, or the Magma controller, to register this access gateway. So this we have to program it. So what we did is through the CBA, we just programmed the whole thing. So what I'm going to do is now I'm going to show you this. Okay, so I'm running a screen. On the screen 0, I'm going to show you the pods. So here you'll see all the EMCO pods and the CDS is running in. And I'm going to connect to the CDS Python executor pod, which is the reason why is because we have built up a CBA using the Python. So that's why we are interested to see when we run the CBA, all the logs corresponding will be generated in this pod, and we can see the how actually the things has happened. Okay, so we are just connecting there. We'll tail on to one of the artifacts.logs. Yeah, so we're going to tail here, and the next tab, this is the curl command to trigger the CBA. So CBA is already loaded, and what we're going to do is we're going to trigger it, and also we're going to monitor the NMS pod to see all the get operations and the the post or delete operations which we're going to do. Right, you can just see here all the logs to verify. Right? And we're also seeing that now Magma orchestrator pods are all running up here. And this is our the first VM 101224. Okay, now let's trigger the CBA itself. We'll go to the shell 1. Yeah, I'm going to hit this curl command now. So here, before that, what we wanted to show here is on the Magma UI, right? The NMS UI. Here we are using the tri network. This is the network which we have upfront created. So one can create this through the REST interface also. And there is a already a gateway ID 3, right? And it's health. If you see, it is in bad state. And what we're going to do is we're going to fetch the details of this gateway ID, and then we're going to delete this and add a new gateway which we just instantiated, right? So remember here. The hardware ID of this gateway ID 3, right, is C1E, and for the new one is a different value. Right? We'll just verify all of that, and it is in the bad state. So we'll just invoke the CBA, and now CBA is going to do the workflow action. So CBA got completed, it ran successfully. We'll go to the shell 0, and we'll see the things now. So here is the CBA. CBA name is Magma Automation. Right? So this is Magma Automation is the name of the CBA, and we triggered the workflow, performing management workflow, and this is where we fetch the hardware key. So you see this value is what we shown you when the access gateway came up, right? So that is the value fetched back. And then we are doing a get operation on the previous gateway ID. If you see, the ID is different here, right? And we showed in the UI also, the C1E was the stale one, right? So we did a get. Now what we're going to do after the get is we're going to unregister this because it's no more active. So we're going to take it away. So we'll do an unregistration operation in the same workflow. So if you look at here, we did a performing access gateway unregistration to this interface, REST API, and then we got a success of it. And then what we did is the new access gateway which we have, right? We are going to register it. So we register it in the same try network, and we got a success of it back. And we will just see this same access, the new gateway has been added, and the hardware ID and the health is all. Look, if you look at the hardware ID is new now, and the health is also good, and the check-in has happened, and the CPU state is also quite healthy there. So this is what we have done as a whole demo part of it. So automation has been done. Now think of, you can have multiple of such access gateways. So you can just automate this whole thing. Yeah, just we are verifying that this was access gateway. Right.
So you can probably leave some time for questions. Maybe let's wrap it up and leave a couple of minutes for Q&A.
Right. So pretty much we are done. This is one more second. I'll just show you the logs of this one. NMS pod, where we'll just highlight the 3 operations which we did through the CBA, right? Yeah. So these are the 3. If you look at it, we did a get followed by delete followed by post, and this is how we verified that our CBA works properly, and we can see in the UI also it's working. Yeah, we can go to Q&A.
So we just have a minute left. So in case anyone has any questions and it goes beyond the time limit, feel free to reach us out, and we'll try to provide the answers.
Yeah, we can take that offline also. Yes.
Yeah, only one good thing. One thing. This is very good. Thank you. One thing that would help is that many times you would have large number of AGWs, right? Could be in thousands. Okay, and maybe it would be good to know what would be the features that are required in EMCO or other communities to make this automation even simpler, right? When you talk about SSH, is it possible to avoid SSH? And should we create some kind of a CRD controller within each cluster, which actually gets this hardware ID and make it available via Kubernetes custom resource? Maybe you might have some thoughts, right, based on what you did so far. That would be good to know.
Yeah, so basically the native form of doing, right? That's what you're looking at it.
Yeah, native form of doing it. And of course, sometimes you need to have some kind of workflow for sure. But how do we, like SSH into remote systems is, many companies don't allow that, right? So so what else we can do? I mean, what are the problems? Any thoughts on that would be good to know.
Yeah, sure. I mean, we'll take that, and I'll get back to you on that part.
Okay. Yeah. Thank you.
So Srini, that's a very interesting point. But at some point, like at least my personal opinion is that we're expecting this entire Magma code base to evolve to be fully cloud native, where we have everything running as a pod, and then we have these REST APIs that we can do to the specific pod and extract the relevant information.
Yeah. And then also, by the way, in the KUD now we support QBot because Botlet is not being supported by Mirantis. So we used QBot. So that could be one enhancement.
Okay. Yeah. That will be a slightly more enhanced version.
Yes.
Right?
Yeah.
That's all. Thank you.
Yeah, I think we've crossed 1 minute over our allocated time. So thank you, everyone. Thank you very much for joining us. And at this point, we'll stop it. In case there are any questions, just feel free to reach us out. We'll upload the presentation into the wiki page and the recording also. Thank you.
Yeah, thank you.
Yeah, thank you, everyone.
Yeah, Jendra, if you could stop the recording and then we will